All right, welcome back. We're going to jump into 7.5 now, which gets into properties of exponents in scientific notation. So we've been dealing with exponents a little bit. We haven't gotten into the technical terminology and things like that. So we're going to do some of that now, and then we'll see some applications eventually. In general, exponents can be thought of as a shorthand for writing repeated multiplications. So for example, if we're multiplying 2 times itself 4 times, we can write it in a more compact form as 2 to the 4th power, where it should equal 16, and then 4 is called the exponent, and 2 would be called the base. So the exponent is how many times you're multiplying it, and the base is what you're actually multiplying times itself. So now, one thing that's important with exponents is parentheses. When they use parentheses in those types of expressions, you got to be careful and make sure you interpret them correctly. So if we were comparing these two different exponential expressions, you can see the one has the parentheses around it and the one does not. Now, the one on the left is going to be written in expanded form using the parentheses on each instance of the -3 because it's in parentheses. So the whole thing is being repeated 3 times. So when we multiply this, we got 3 negatives, and so now it still should be a negative answer. So we're going to get -27. However, on this one, it's not quite the same thing because the parentheses are not there anymore. So we have to interpret this one a little bit differently. So on this one, the negative is outside of the exponential expression. So all they want you to do is take the negative of 3 times 3 times 3. So there's only one negative in this one. And so in this case, it will be negative. So -27. Now, while it doesn't make much of a difference for this problem, it might in other ones. So let's look at the next one. The only difference is now we're going to an exponent of 4. So how does that impact things? Well, the one on the left means we got 4 -3s that we're multiplying together. So because there's 4, is the answer going to be positive or negative? So there's the difference. So in this case, the answer is going to be a positive 81 because there's 4 negatives and they all pair up and cancel each other out. But in this one, you can see we got 1 negative and then the 3 times 3 times 3 times 3. So this one's going to give you a -81. So very, very subtle difference those parentheses make. But if you get a negative versus a positive, that's important. So you got to be careful with that. Okay, so that's just one word about being careful with parentheses and negatives. But how can we do stuff quickly with exponents? So for example, if we were multiplying 2 to the 4th power times 2 to the 3rd power, how could we do that and maybe find a shortcut for it? You might already know this. And the one way that we can see what's happening is to expand it out. So if we expanded it out, we're going to get 2 times 2 times 2 times 2. So there's 4 2's. But then we're multiplying it by 3 more 2's. Now, if I remove the parentheses, how many 2's do I got? I've got 7 of them. So I can write this as 2 to the 7th power. Now, that's fine, but what happens when you get a really large exponent on some of these? You don't want to have to write out 15 2's or something like that. So what's the shortcut? The shortcut is look at the exponents, what we started with, and compare it to what we're ending with. What's the trick? The trick is to add. So if you add those exponents together, that will get you to your answer quicker. So that's the first rule that we're going to look at. So it's the product rule. If we're multiplying things with the same base, that's key. They have to have the same base. Both of these have a base of a. Then you can add the exponents together. So in this case, we're dealing with x as our base. So all we got to do is add those exponents. So x to the 12 plus 4, which is x to the 16. Done. Now, what about something like this? We got these numbers in front here, 7 minus 2 and the 4. What do we do with those? Well, kind of ignore the k's for a minute. And what are we doing? We're multiplying everything. So you just flat out multiply those numbers in front. So 7 times negative 2 is negative 14 times 4 is negative 56. So we got a negative 56 for our numbers. So now those are gone. And now let's look at our k's. We got k to the second, we got a k, we got k to the fifth. So what's our exponent going to be on our k? 7? Well, be careful. When there's not an exponent on something, we have to pretend there's a 1 there. So there is an 8th k. So we got 8 k's. K to the 8th power. All right, let's try one more. So again, our numbers in front, we got 3 and a negative 4, so we can multiply those to get negative 12. Look at our a's. We got a to the second, and we got an a, so let's squeeze a 1 in there. So that's a to the third when we add them all up. And then we got b to the third and b to the third, so that should be a b to the 6. So not terrible. You just got to be, again, you got to be careful. All these things you have to be careful with. So let's take a look at another rule. Negative exponents. Negative exponents? Yuck. Well, there's tricks to this. The trick is you want to get rid of the negative and change it to a positive. But how do you do it? Well, there's two cases that we have to know how to take care of. Essentially, this first one has a negative exponent, and the way we can think of it is that it's in the top of a fraction. So if we have a negative exponent in the top of a fraction, this is how you get rid of it. You drop the negative, and then you move it down into the bottom. And that's it. The a stays the same, but the exponent changes to a positive when it moves to the bottom. Just the opposite when it's in the bottom to start with. So if you have a negative exponent in the bottom of a fraction, you can move it up to the top, as long as you keep the a the same and just change the exponent to its positive. And that's it. And then we're going to see some ways to simplify in the next rule. But for now, all we're doing is getting rid of the negative and just simplifying if we can. So for this one, 7 to the negative 2, well, it's in the top. So now we got to move it down to the bottom. So because we're taking the whole thing out of the top, that's why we have to leave a 1 behind, because you don't want just a void in the top of your fraction. So we need to leave that 1 there. So we had 7, and then it's going to be a positive 2. So what's 7 to the positive 2? That's 49. So your answer should be 1 over 49. All right. Now we got a little bit of a mess here. We got a negative 4. We got negative 3 exponent. So what do we do? Well, the first thing we notice is that it's in the bottom. So we got to get it up to the top. So if we move it up to the top, that changes the negative 3 into a positive 3. But what happens to the negative 4? Absolutely nothing. The negative 4 stays in negative 4. Only the exponent changes. Now, if you want to put it over 1 just to kind of keep that symmetry, that's fine, but you don't need it when it's in the bottom. So now we just have to simplify this down. So negative 4 to the third power, negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. So that should be it. The last one's a good one, because now you've got two negative exponents. So we got to move them both. So the top one goes down to the bottom, and the bottom one goes up to the top. So 3 to the positive 2 better go up to the top here. 5 to the positive 1 better go in the bottom. And so now 3 to the second power better be 9. 5 to the first better be 5. Done. All right. Well, so now we have two rules. We got the product rule and we got the negative exponent rule. Let's see how those work to help with the next rule, which is going to be the quotient rule, in the next video. See you in a minute.